Okay, so today we are still working with inverse trig functions, but now we are doing composition of inverse functions. So sometimes, depending on the way it's written and the input, the function and the inverse function will cancel out, and I'm just left with my number. If it's not in the domain, I won't get an answer. So for example, if I'm finding the inverse sign first, and then I'm finding sine, it needs to be between -1 and 1. If I'm going in the opposite order, so I'm finding sine first, and then I'm finding inverse sine, it needs to be between -pi-halves and +pi-halves. Same thing for cosine and inverse cosine. So if I'm finding inverse cosine first, it needs to be between -1 and 1. If I'm finding cosine first, it needs to be between 0 and pi. If I'm finding inverse tangent, it will always work if I'm doing that one first. And then if I'm going the other way around and I'm finding tangent first, it will only work on -pi-halves to pi-halves. So, according to these rules, I am finding inverse tangent first. So, is this in my domain? Is it a real number? Yeah. So here, my tangent and arctangent cancel out, and my final answer is just -5. Yes. Okay. So next one. This one I'm finding sine first. Does 5 pi-thirds, is that in between -pi-halves and pi-halves? No? Where is 5 pi-thirds on here? What quadrant is 5 pi-thirds in? So it's actually in here. Is that where I care about for sine? Yes. So I just need to convert it to an angle that is negative. It goes in between these two. Jamie. So what? I need to convert this to a negative angle. What do you want me to do? How can I make a positive angle into a negative angle? We did this earlier this chapter. Okay. I'm in radians, so I'm going to subtract what instead? 2 pi. And what does that give me? -pi/3? Okay, so I can rewrite this as arc sine of -pi/3. So because -pi/3 is in that domain, my arc sine and sine will cancel out, and my answer here is just -pi/3. Why what? So -pi/3 and 5 pi/3 are coterminal. So they're equivalent, and it means they just land in the same spot. My answer for whenever I find arc sine needs to be a radian measure. And for arc sine, it's always in between -pi-halves and pi-halves. So that's why I had to use a coterminal angle to change where or what I was writing so it fit in that range. Because like technically 5/3 is right, but it's not in that range. So I just needed a coterminal angle that is in that range. 5/3 though is not between negative 5/2 and 5/2. Right? 5/3 is more than 5/2. Oh yeah, the actual angle itself ends up there, but the number 5/3 is not in between there. So that's why I rewrote it as a negative angle. Because the angle is there, I just need to write it as the negative version of that angle.
So instead of like going all the way around,
So like think about it this way. If you ask me what time it is, I'm not going to say it's 18 o'clock, right? I would say 6. It's just kind of the same thing. I'm just changing it to a more normal way of saying it.
So would we always?
Yeah, you always want to convert it to see if it's in the 4th quadrant.
So if it's in one of these quadrants, we still do this, and if that answer is outside the quadrant, we use the original number?
If it's in the other 2 quadrants, then I wouldn't do it. Like if it's in 2 or 3 for sine and tangent, I wouldn't use that angle. But if it's in 1 and 4, I can subtract or add 2 pi to make it fit between negative 5/2 and 5/2. Okay, so number 3. I am doing inverse cosine first. Is pi in between negative 1 and 1? No. So this one is not in the domain. Okay, so these ones, guys, notice these ones are not the same inverse. This one's tan, arc, cosine. So what I want to do here is I actually want to draw some triangles to help me solve. So cosine, remember, is adjacent over hypotenuse. So I'm going to label my adjacent 2 and my hypotenuse 3. And then what do I need to solve for tangent? I need my opposite side. So what am I going to do to find that? The Pythagorean theorem. So what should I write on my paper? Okay. And how come I didn't put that 3 in for B? And hypotenuse is always C. Okay. So then I'm going to solve. 2 squared is, oops. And 3 squared is 9. Then how do I get B alone? 9 minus 4 is, so then I square root it, and that is my side length here. So tangent is going to be what? Square root of 5 over 2.
That's your answer?
Yeah, that's my answer. Okay. So questions on number 7. Almost. Number 8 is negative. So this is going to change something. Because tangent's opposite over adjacent. Okay, so for number 8, my arc sign is evaluating a negative number. Which quadrant is this in? Sine is, when we're looking at inverse sine, which two quadrants am I always looking at? The first and fourth. So where is sine negative? The fourth quadrant. And then sine is opposite over hypotenuse. Remember, when I'm working with negatives, it always goes with the side that isn't the hypotenuse. So my negative 3 is going to go over here, and then my hypotenuse is going to be a positive value. So what do you want me to do next? Find my missing side. So what am I going to write on my paper to find that? Okay. So something I noticed when you guys were doing the Pythagorean theorem earlier on your homework is when you do negative 3 squared, sometimes we forget the parentheses. Remember, I'm multiplying two negative numbers here. Negative 3 times negative 3 will always result in a positive number, which is 9. And then 5 squared is, okay. So when I subtract 9 on both sides, and I get 16. And then I could go ahead and square root. 16 is a nice number to take a square root of. It gives me 4. When I write my 4 up here, is it going to be positive or negative? Positive, because x values are positive over here. Okay? So then I just need to find cosine. Cosine is adjacent. Questions here?